Assalamu alaikum wa rahmatullahi wa barakatuh. I will discuss a 3-terminal IC, that is SMPS controller, top switch, TOP224Y. This IC looks like a transistor, but it is a SMPS controller IC. It is TOP224Y. We will study this diagram and then we will see practical function of this IC and this circuit, and how it works practically. Which type of faults will occur in this circuit we will discuss, and we will see with theory and practical. If you are watching my video first time, so subscribe my channel, and if you want to watch my future videos, you can press bell icon button. It is up to you. Let's start. This IC works from 85 volt to 265 volt, so very wide range operating voltage, and it is used in buck operation. Here we have a fuse class X capacitor for high frequency spikes and voltage protection. Then we have EMI RFI filter. Then we have bridge rectifier. It is using 4007 diodes. Then we have 5D11, that is inrush current protector. When the capacitor is discharged fully and we are turning on this circuit very first time, so we apply voltage. So this capacitor is fully discharged. So discharged capacitor works as a fully short circuit. So it tends to draw full current. So this 5D11 NTC, negative temperature coefficient resistor, it blocks the huge amount of current and it allows a limited current to charge this capacitor. When the capacitor will charge, at that time it will allow the normal running current. So this NTC will protect the next circuit and the previous circuit. So it is a protection, current protection. So for current protection we have NTC, we have fuse. Voltage and frequency protection, we have EMI filter, RFI filter. After that we have primary winding here of this transformer. This primary winding is, one end is connected to this capacitor, the second end is connected to this IC, and this IC second end is connected to main DC capacitor. We have line and neutral. This line will go here. After that it will enter in the fuse. Second end from the fuse, it will go to capacitor. Here we have a capacitor, this one class X capacitor. Then we have dual line filter. It have two inductors, one for the line, second for the neutral. So after passing this inductor we have a bridge rectifier. We have 4 diodes here, 2 diodes for one line, so we have 4 diodes here. After that we have here NTC, this one 5D11. So the AC line will reach here at this point and this point, because AC enters from here and reaches here. AC enters from here and reaches here. So this end and this end. So we have 4 diodes, 1, 2, 3, 4. 2 lines, 2 for positive rectification. So in positive rectification, rectified line, we have NTC and it is reaching here at this capacitor. And the negative side is connected to this capacitor. So this capacitor will charge as a output of this bridge rectifier. And negative side of this capacitor, here we have 100 microfarad, 400 volt. Negative of this capacitor is connected to source pin. Source, and this negative line is connected also to this capacitor, VCC capacitor, and it is connected to auxiliary winding one end. And it is also connected to class Y capacitor. We will discuss step by step. As we discussed, the main DC ground side, primary DC ground, is connected to this IC source pin, because this IC have only 3 pins. Basically this IC TOP224, it is a set of ICs, not a one IC. So it have 8 pin and it have 3 pin configuration. In this power supply it is using 3 pin IC. So ground is connected here, positive line is connected here, and this IC, it have built-in chip and built-in MOSFET. The internal circuit will switch at 100 kilohertz, 100,000 hertz, 1 100 kilohertz. That means 100,000 times switching in 1 second. So it have internal MOSFET switch. So it will switch, its internal switch will make break like this. What will happen? The negative voltage, the negative line will connect it to this primary. How many times? 100,000 times in 1 second. That is called 100 kilohertz or 100,000 hertz. One piece of the switching cycle from here to here. You can say I will make one cycle. It will start the switch, turn on the switch, then turn off. From this point to this point, one switching cycle. And how much repetitions? In 1 second, 100,000. So this switch will operate 100,000 times in 1 second. When it will switch will make, this point will closed, so negative line will switched and positive voltage are available already at the capacitor, at this transformer. What will happen? When we apply voltage to a inductor, to a coil, it will cause to run electrical current in the winding. And we know when we apply electrical current to an inductor, it generates magnetic fields. When the magnetic field will expand, it will also cut this winding, the other windings placed near to it, so that it will cause to induce voltage in the inductors. Varying magnetic field is present at any place, and we put some conductor in this magnetic field, so this magnetic field will cause to induce voltage in that inductor. So here we have this conductor, this inductor, this coil, so it will cause to induce voltage in these windings. In first turn on time, when we turned on in one cycle turn on time, this is on time and this is off time. So in this way it will induce magnetic field. When the magnetic field will, here we have voltage in secondary, we have voltage in auxiliary winding. When this switch will open, because here we have off time, in the off time, when the magnetic field will collapse, because now there will no current because this switch is open, so this inductor is now open ended, this end will open because this switch is now open state. When it is open state, so this magnetic field will collapse. This collapsing magnetic field will cause to induce reverse voltage to the applied voltage. Its polarity will reverse. So first this end was positive, now this end will become negative and this end will become positive. So negative, positive, negative, positive. So it will cause to apply double stress to the applied voltage. If here are, for example, we have 300 volts, in the collapsing time, in the off time, in this period, the MOSFET will get 600 volts. So it will damage this MOSFET. To protect this MOSFET, this switch, there is a snubber circuit. It is protection circuit for the MOSFET. RCD, a resistor, diode and capacitor. So in that time, this end was positive, so this diode will become forward bias and it will charge this capacitor and it will also discharge voltage from this resistor. So in the off time, this circuit will activate and it will discharge this winding. It will reduce the excessive stress on this MOSFET. So this IC will get ready for the next cycle. Moving on the same point, as we discussed, the magnetic field will cut the auxiliary winding, VCC winding. So from this winding we will get voltage and these voltage will rectified and these voltage will reach at optocoupler. Optocoupler basically is a IC and it communicates with hot side and cold side through a varying light. The varying magnetic field in the primary will cause to induce voltage in the secondary, so that this voltage will rectified in the secondary and it will charge this capacitor, and we have a filter. After that we have a final capacitor for output, that is output capacitor, and we will take 5 volt output here. This power supply have multi output, but I will discuss just only one winding, one circuit. From this point, when we will take 5 volts, we have a voltage divider network. At this point, we will make a voltage divider network. It is 1.54K and 1.5K resistor. And we have TL431 voltage adjustable voltage zener, voltage regulator. TL431, and we have one capacitor here, 1 microfarad, 50 volts. Now when we take 5 volt, at that time, at this point, pin number 1 of TL431 will receive 2.5 volt. It works as a zener regulator, but we can adjust its regulation. We have one resistor here, 100 ohm. This 100 ohm resistor is connected in the output of this rectifier at the capacitor, first capacitor. Here we will find the ripples, and it will monitor the ripples, it will monitor the load. Now when we will take here 2.5 volt at this point, because we have voltage divider network composed by these two resistors, and we will take voltage at pin number 1. Pin number 2 is grounded. When this reference regulator will take 2.5 volt, at that time it will allow some voltage, 1.3 volt output here, and this voltage will apply to this LED. The second end of this LED is connected to positive line. So from this point to this point we will receive at this pin and this pin 1.3 volt. 1.1 volt will drop this LED, and 0.2 volt will drop by this resistor. So when we will receive 5 volt, when this level will maintained at this point, we can say it is a sense circuit for this regulator. When we have 5 volt, so this is feedback circuit, this is a sense line, it is working as a remote sensor. Anytime we have 5 volt, at that time this will allow to conduct this LED, and when this LED will conduct, this transistor will switch, because this transistor have optical window, it will receive light emitted by this LED, so it will conduct and it will pass these voltage to the control pin, and it will cause to charge this capacitor 47 micro 50 volt. 10 ohm resistor is used to limit the current. And here we have a class Y capacitor. This capacitor is used to remove the switching noises, conduction noises, and the load noises. From here we applied AC. We receive DC voltage after this network. Here we make purification, rectification. Purification from high frequency harmonics, high voltage, any noises in the line voltage. So we will receive 60 Hertz or 50 Hertz at this point. And this network will protect external circuit and internal circuit from all the noises. So it is a barrier. It will just allow 60 Hertz to enter the circuit, 50 or 60 Hertz. Here we receive DC, and here we make switching. So this switching will cause a varying current in the primary. How much is frequency? 100 kilohertz, 100,000 times oscillation in 1 second. So it will cause to induce voltage in the secondary. When we will receive 5 volt here, our this network will give a feedback, and it will allow to produce these voltage, these rectified voltage at control pin. So this IC will adjust its duty cycle. What is duty cycle? This is one cycle. From one cycle, turn on time, Vs turn off time, how much time it will turn on, how much time it will turn off. This ratio, on time Vs off time, is called duty ratio, duty cycle. So it is used in regulation. When we have load here in the secondary, so it will cause to drop voltage here. When it will drop voltage, at this point will another voltage drop. So this drop will make changing voltage at pin number 1. So it will cause to disconnection in PC817 optocoupler. So optocoupler will stop the feedback. So in that case, this IC will enlarge its switching time. It will increase. First it is increasing in this time, then it will increase like this. So it will turn on for more time. From one cycle, it will allow more time to flow the current. When more current will flow in primary, more magnetic field will, strong magnetic field will build up. So it will cause to induce more voltage in secondary. So we will receive more voltage and it will compensate the loading effect. Let's see the circuit. Friends, if you have no good practical knowledge about electronics, never make a practice on these circuits because dangerous electrical voltage are here. As we discussed, negative line is connected to source. Drain pin is connected to this winding. Here we have this transformer. This is high frequency transformer. So positive line is connected to one winding. Second line is connected to this side. So here we have winding here. And here we have winding. This is primary winding, this is auxiliary winding, VCC winding, bias winding, whatever we say. And here we have multiple windings in the secondary. I discussed only just 5 volt section because this circuit is monitoring just only 5 volt. The other voltage, other lines will regulate it automatically with a reference with 5 volt. Here we have one connection here at this point. Here we have one diode, this one. So this diode, resistor, capacitor, RCD, resistor, capacitor, diode. So it is our snubber circuit. So it is connected in parallel of this winding. We can see this diode. After diode, we have capacitor, we have resistor, and it will discharge in the off time. Now, this line, ground, this IC will switch the ground to this winding. So this winding will make magnetic field. So this magnetic field will transfer in the secondaries and other windings. In the meantime, we will receive voltage at this winding. This is our bias winding. So this bias winding voltage will rectified through this rectifier. We have one rectifier here, this one. It will rectify the voltage, and these voltage are applied to this optocoupler. These rectified voltage are applied to this optocoupler. This point. When this will switch, it will pass light from, this is diode side, LED side, and here we have transistor. So it will allow this voltage to pass from this point to control pin. This is control pin. Drain, source, control. We can say it is feedback pin. We will discuss all this family top switch in our next video, because if I will discuss in the same video, it will become too much lengthy. So here we have a resistor, 10 ohm resistor. This one, it limits the current. And we have capacitor, VCC capacitor here. This is our 5 volt section, this diode, this rectifier. And we will find voltage here. Then we have capacitor here. This is ground line, and this is 5 volt section. So it will charge this capacitor. When we will find voltage here, and then we have the same line. We have, as I discussed, we have one capacitor, we have inductor. Where is the inductor? Here we have inductors, this one, and this inductor. After inductor we have capacitor here, this capacitor. This is the output capacitor, and we have here zener regulator, and this point is 5 volt output, and from 5 volt output we have a jumper. From jumper the same line is going to this point. See again, output of the diode, one capacitor, inductor. From inductor we are taking this voltage here at this point through jumper here, and we receive voltage here. What is that? Here are two resistors. 5 volt line is connected to one resistor. 5 volt line is connected to one resistor. It is 1.54K, 1540 ohms. This resistor is connected to another resistor here, and this resistor is connected to this point. One resistor connected to 5 volt, connected to second resistor, and this is connected to this line. This is our return line. Positive 5 volt, center point, ground, and this point is connected to this TL431. What is that? It is here. The same common point of two resistors are connected to TL431 pin number 1. Here we have TL431 pin number 1 inside. So here pin number 1, and here we have a capacitor between pin 1 and 3. It is to protect false switching, false signals due to spikes and other errors. So this capacitor 1 microfarad, it is connected here. Pin number 2 is connected to ground, the same ground here. When it will receive 2.5 volt at this pin, at that time it will allow to pass 1.3 volt from this TL431. So it will 1.3 volt will apply to this optocoupler. Optocoupler second end, pin number 1 is connected to one resistor here. This resistor, 100 ohm resistor, is connected this line, and it is connected to this point. What is that? It is the output point of the rectifier. Here we have rectifier, and this thin line is connected to this resistor. What is that in the diagram? We have one line connected to resistor and is connected to optocoupler. So anytime we apply more load, it will cause to draw current, and it will cause to drop voltage at this point. So this dropping voltage will sense at this pin, and at the same time here, how much voltage drop is here, it will change the conduction level, and it will change the light of this optocoupler. So it will cause to make more switching. So let's see. Now I will connect power. Set multimeter to AC voltage. Friends, never touch hot side. From transformer to input terminal, it is called hot side. Why? Because it deals with line voltage, and after transformer it is called low side, cold side. Never touch this portion by your hand, by your finger, so it will risk of electrical shock. And always use series lamp and isolation transformer for your protection and safety. First of all, check voltage at this terminal. It is 231 volts. Now if you want to make a good tracing the circuit, connect one pin test probe to one line and move line like this. Second probe here, we find voltage here. It works like a water pipe. The water is flowing in the pipe. So if you consider this circuit is working like a pipeline, so it is very easy to trace. Check this point. Here we have voltage, and what is there? Here is a fuse. From the current will enter in the fuse and it will go outside from this fuse. So put the same point here, and here we have one line, and move the multimeter to the second side of this fuse. If you find voltage here, that means our fuse is good. If you find voltage at the one side and we cannot find the voltage at the second side, that means the fuse have disconnection. At that time we have to check the fuse. Move at this point. So this track is working good. Sometimes the tracks looks good, but it is disconnected internally. So here we have voltage, then we have dual line filter. Move to the second end of this filter. Then we have bridge rectifier. Now we have, for example, when we connect fuse blows up immediately. It burns out. What is the problem? The first we have to check this capacitor. If this capacitor is short circuit, for example, if this capacitor is short circuit, it will allow the complete current to flow from the fuse and it will damage. And if we have this bridge rectifier bad, this diode is bad, for example this diode is bad, so it will damage this circuit here. If this fuse is bad, this diode is bad, so if bridge rectifier is bad, this circuit, this fuse will burn out. This capacitor is damaged, this fuse will burn out. This MOSFET, this IC is bad, this fuse will burn out. So here are some key points for protection of fuse, for checking of the fuse. So we have to verify. I uploaded a detailed video. I will give the link in the description so you can follow how to troubleshoot the short circuit protection, short circuit detection in the primary side. At the input of the bridge rectifier, we will find here AC voltage. Now move the switch, move the multimeter to DC voltage. At capacitor, main DC capacitor, we should find voltage here, stable voltage, rectified 325 volts. Here I applied 232 volts. Multiply it with 1.414 and the check resulted voltage, this voltage at this point. Multiply 1.414 and the same voltage should here. If it is coming 325 volt, calculation says 325 volt, that means this capacitor is good, this circuit is good. If we find this voltage, this rectified voltage here, but not 325, it is around 220, 230, that means this capacitor is open from inside, so you have to replace this capacitor. I discussed why we have to multiply with 1.414, so you can check that video. I will give the link in the description. Now the first point, this voltage must be stable. If we have varying voltage, that means we have something wrong in the circuit. Then the next step to test this circuit, we have to verify this capacitor, VCC capacitor. It is small capacitor connected near to this IC. Any IC, 3842, 3843, 42, SD, serial, TNY, top switch, wiper, every IC should have this VCC capacitor. Most of the ICs use this capacitor. So we should find stable voltage. This IC requires 5.8 volt. Some ICs need 15 volt. Some ICs need 20 volt. So what is the requirement of that IC? But this voltage must be stable. This voltage stable, this voltage must be stable. If we find stable voltage, that means the circuit is stable. Now let me give some example. For example, I have short circuit in the secondary. Any component is bad in the secondary. We can see the multimeter, it is switching, it is varying voltage at the capacitor. So this point will fluctuate. At VCC capacitor, any IC, VCC capacitor must be stable. If we have anything short circuit, we can see the fluctuation. So if anything short circuit, any component is bad, for example, I have bad capacitor. In any case, we have fluctuation. Then we have something wrong in the secondary side. If our circuit is working stable, our VCC voltage should stable. From this point to this point, we should have the output voltage. What are that? It is here. Here we have two resistors here. It is working as a voltage divider network. When we will receive 2.5 volts at this point, 2.5 volt, that time it will give feedback to this optocoupler. It is 1.1 volt. This is ground line. When we will find 2.5 volts at pin number 1 of TL431, so it will allow 1.3 volt output. We received 2.5 volt at pin number 1. Pin number 2 is grounded. So between pin number 3 and the main VCC line, main output, pin number 3, from pin number 3 and main output, we should find 1.3 volts. So it is output, pin number 3, and it is output line. Output of this TL431 and the output line, here we have resistor, current limiting resistor. It is 0.2 volt drop and 1.1 volt for this optocoupler. So when it will receive 1.1 volt, it will switch this transistor and we will receive the voltage, rectified voltage. Now we have to see a very good point. From auxiliary winding, the rectified voltage are 11.5 volt, but the output of this optocoupler is 5.8 volt. This is ground line and the output of this auxiliary voltage is 11.54 volt. But when we receive 5 volt here, it will allow a limited switching. So it will cause to pass voltage 5.8 volt. It is receiving 12 volt. It is receiving 11.54 volt, but it is passing just only 5.8 volt. So it will receive, this IC will receive 5.8 volt at control pin so that it will switch. Now, if any rectifier is bad, any capacitor is bad, any component is bad, regulator is bad, this IC will make fluctuation. It will make restart again and again. To find this 5.8 volt, it need these 5.8 volt at any case. For a stable switching, it requires 5.8 volt. Due to any problem, this capacitor is short, so it will not allow to maintain 5 volt here because it will discharge all the voltage from here. If this capacitor is bad, if this diode is bad, this circuit is open, anytime we will not find voltage here, or the load connected here is short circuit. At that time this voltage will not appear at pin number, this output pin, so it will not take 2.5 volt here. When it will not 2.5 volt, it will not allow to switch this optocoupler, and at that case we will not find voltage at this control pin. So this IC will make on, maximum on, and it will charge internally from its reference voltage. So it will charge internally because this switch is not operating, because it is not working. So it will make oscillation, it will charge, and after that it will not fulfill the current requirements, then this IC will turn off. So on off, on off, on off, this is called fluctuation. And this fluctuation is obtained when we can see the conditions. For example, optocoupler is not working properly, we are finding fluctuation and VCC voltage. This rectifier is bad, we have fluctuation. We have bad capacitor, we have fluctuation. Any component will bad, our circuit will fluctuate. The second thing, our circuit tries to work but it cannot provide the voltage. At that time we have to check this snubber circuit. If the diode is bad, at that time the primary will not discharge fully, so that time we have a drop in voltage. If any capacitor is short internally, that time it will not maintain the output. So friends, if you have any question, please let me know in the comment box, and if you have not subscribed yet, hit the subscribe button, and if you have any question, please let me know in the comment box, and share this video with your friends. Might be it may helpful for someone. So remember me in your prayers. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.